Continuity in Calculus by Halen Manabusen and Lucas Chaney. Continuous functions do not have any breaks in them. You can think of them as functions that you can draw without lifting your pencil. This includes corners and cusps. Non-continuous functions have breaks in them, such as jumps, where the function stops and continues on another path like a piecewise function, removable discontinuities, where it appears to be a continuous function but has a single point missing, and infinite discontinuities, which have asymptotes that separate parts of the function.
This theorem states that a composite of two functions is continuous if one part of the function is continuous at point C and the other part of the function, the outer part, is continuous at f of C.
The intermediate value theorem for continuous functions states that if a function is continuous on a closed interval ab, then there is a value for every x from f of a to f of b.
This example presents a function and asks for the points of discontinuity on it. The function has two such points in the domain 0, 4. The first, at x equals 1, is a jump discontinuity with the function approaching 0 from the left and 1 from the right. The second, at x equals 2, is a removable discontinuity. The function approaches 1 from both directions, but f of 2 is 2, creating a discontinuity. This example asks one to find the points of discontinuity and the points of continuity of the greatest integer function, y equals int x. The function is not continuous at every integer, as it jumps to the next integer y at each integer x. It is continuous everywhere else, as the y value doesn't change except at those integers. This example shows how a function can have a point of discontinuity but remain a continuous function. Since a continuous function is a function that is continuous on its domain, rather than for every x, a function that is undefined at some x is continuous despite the infinite discontinuity at that x. This example shows a composite function and uses the composite of continuous functions theorem discussed earlier to prove that it is continuous. The two functions it is a composite of, g of x equals absolute value x, and f of x equals x sine x divided by x squared plus 2, are both continuous. Thus, the composite of these functions must also be continuous.
The intermediate value theorem tells us that there must be a point C between 1 and 2 where f of c equals 0. We know this because the value at 1 is less than 0, and the value at 2 is greater than 0. Most calculators, such as the TI-84 Plus, have the zoom and trace applications, which allow you to find the C value accurate to 3 decimal places. Thank you.